Imagine something so thin it's practically two-dimensional. A single layer of atoms, stronger than steel, more conductive than copper, more flexible than rubber. This isn't science fiction, this is graphene. We call it a super material for a reason. It holds the potential to reshape our civilization. To understand it, we must journey down to the atomic scale. We must look at the building blocks of matter itself. The universe has hidden this marvel in plain sight. It's been waiting for us to discover it, and we found it in one of the most common materials on Earth. Think about the pencil you used in school. The lead isn't lead at all. It's a substance called graphite. Graphite is made of countless layers of carbon atoms. They are stacked like a deck of cosmic cards. For centuries we used it to write our stories, solve our equations. We never realized what lay within each individual layer. Then, in 2004, two scientists at the University of Manchester did something remarkable. They used a simple piece of sticky tape. They peeled away a layer from a block of graphite. They kept peeling again and again, until they had isolated a single sheet. A sheet just one atom thick. That single sheet is graphene. This discovery was so profound, so paradigm-shifting, that it earned them the Nobel Prize in Physics, because they had unlocked a material with properties that defy our everyday intuition. It was like finding a secret level in the video game of reality, a cheat code written into the laws of physics. Let's talk about strength. Imagine a sheet of plastic wrap. Now imagine that sheet was strong enough to support the weight of a full-grown elephant. That gives you a sense of graphene's power. On an atom-for-atom basis, it is the strongest material ever tested. It's about 200 times stronger than structural steel. Yet it is also impossibly light. A single sheet of graphene large enough to cover an entire football field would weigh less than a single gram. This combination of feather-light weight and Herculean strength is something we've only dreamed of in a material until now. It's a paradox of nature, but its strength is just the beginning. Graphene is the thinnest material known to existence. How thin? It is 1 million times thinner than a single human hair. It's so thin, it is considered a two-dimensional object. It has length and width but virtually no height. This makes it almost completely transparent. A single layer of graphene absorbs only about 2.3% of the light that passes through it. You could stack dozens of layers, and it would still be nearly invisible to the naked eye. This thinness also makes it incredibly flexible. You can bend it, stretch it, and twist it like rubber without breaking its atomic bonds. Now let's add another superpower to the list: conductivity. Graphene is a superstar when it comes to conducting electricity. Electrons can zip across its surface with almost no resistance. They move more freely through graphene than they do through copper, which is the standard for electrical wiring. This means it can move electrical energy with incredible efficiency, generating very little heat as waste. But it doesn't just conduct electricity well, it also conducts heat better than any other known material. It can spread thermal energy quickly and evenly across its surface, making it an ideal material for dissipating heat. So, let's recap the cosmic recipe for this wonder material. How will these properties change our world? Let's start with the device you might be using right now. Your phone, your tablet, your computer. Graphene could make them faster, thinner, more powerful than ever before. Imagine flexible roll-up screens that are also shatterproof. Because graphene is transparent, conductive, flexible, it's the perfect candidate for creating bendable touchscreens. Its incredible processing speed could also lead to computer chips hundreds of times faster than today's silicon-based ones. Our gadgets could become as thin as a sheet of paper and as durable as a sheet of steel. Now let's journey into the world of medicine. Graphene's unique structure opens up new frontiers. Because it's just a single layer of carbon atoms, it can interact with biological systems in fascinating ways. Scientists are exploring how to use it for targeted drug delivery. Imagine tiny graphene carriers, loaded with medicine, that travel through your bloodstream to find and treat only the diseased cells, leaving healthy ones untouched. Its electrical sensitivity could also be used to create revolutionary biosensors. These sensors could detect diseases at the earliest stages just by analyzing a single drop of blood or saliva. The energy sector is another area ripe for a graphene revolution. Our planet needs cleaner, more efficient ways to generate and store power. Graphene can help. Its huge surface area and excellent conductivity make it promising for next-generation batteries and supercapacitors. These energy storage devices could charge in seconds instead of hours. They would be lighter, last longer, and hold far more power than the batteries we use today. Graphene could also improve the efficiency of solar cells. So when will this graphene future arrive? The journey from a laboratory discovery to a product in your hands is a long one. Scientists and engineers are still figuring out the best ways to produce high-quality graphene in large quantities and at a low cost. This is the biggest hurdle we face. Making tiny flakes in a lab is one thing. Manufacturing giant, perfect sheets for industrial use is another challenge entirely. But with every passing year, we get better at it. We are scaling up production, we are refining our methods, the momentum is building, the universe is made of stories. The story of stars, the story of life, and the story of consciousness. The discovery of graphene is a new chapter in our own story. It's a tale of how we reached down into the very fabric of reality, pulled out a single thread of atoms, and found that it was woven with superpowers. This simple sheet of carbon atoms, arranged in a perfect pattern, reminds us that even in the most common materials, the universe has hidden extraordinary secrets, just waiting for us to find them.